Hi everyone. Today we're going to do classwork 12.2, and it's just a continuation of what we were doing in 12.1, so the interior and exterior angles of polygons. I'm pretty sure I fixed yours. Those are the instructions for all the way up to number 10. We want to find the measure of one interior angle in each polygon. Again, you need your calculators. If you don't have them, go get them, stop the video, and come back when you have your calculator. Okay, we have two ways of doing this. As I said, I love the 360 on the outside. So really, I believe the hardest part of this is counting, really, because it's a pain in the neck. So if you want to try and do these and then see what I get for my answers, if you want to do it without me, that might be a good idea. Just make sure you have the same thing I do at the end, all right? Okay, for those of you that don't feel that confident with it, then just do it with me, okay? All right, I'm going to go for the 360 on the outside. All right, so I have 1, 2, 3, 4, 5 sides. There's 360 on the outside, so 360 divided by 5 is going to give me 72. That's the exterior angle. So to find the interior angle, I just subtract that from 180. Some of you can do this in your head, but I'm going to take the time to do it a little slower. All right, so 108 is the interior angle. Good? All right, the other way I could do it is find the sum. So let's do that with the second one. 1, 2, 3, 4, 5, 6, 7, 8 sides. So this one's an octagon. If I wanted to, I could say, well, 8 sides, so 6 triangles. So the sum of the interior equals 6 times 180, and that's 1080. Divide that by 8, because there's 8 angles, and that would be 135 for an interior. All right, do you see how much faster it is if I work from the outside? Or I think it is. All right, so let's do number 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I hope I got that right. All right, so 360, there's 11 sides, so 11 angles. 360 divided by 11 is 32.72 repeating. That's my exterior. So 180 minus second answer. Again, the answer key is on the negative at the bottom right. So the interior equals 147.27 repeating. Okay, number 4, 1, 2, 3, 4, 5, 6. I have 6 angles, so an exterior is 360 divided by 6, which gives you 60. Hopefully you can do that one in your head. So the interior is 120. Okay, let me slide it up. Okay, so number 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sides, so 9 angles. 360 divided by 9. That's going to give you 40. Again, you might be able to do that one in your head. That's your exterior. So your interior equals 140. Number 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 360 divided by 12 is going to give me 30. That's your exterior. So your interior is 150. All right, does everybody see how the more sides I have, the more and more it looks like a circle? All right, so 24 are gone. All right, so 360 divided by 24. So 15. Double check that. Yep. So that's your interior. 180 minus the 15 is going to give me 165. 23, so I have 360 divided by 23. And that's going to give me 15.6522. Again, you have a repeat there. I don't know if you could tell what it is, though. 15.652, and that has to be a 2 because I'm going to go 4 with it. And now do 180 minus second answer. And you should have 164.3478. That's your interior. A regular quadrilateral. Regular quadrilateral is going to be a square. Okay, so this one you can kind of remember. In a square, I'll write that down just so you pay attention to it. The interior and the exterior would be 90 degrees. 16, so 360 divided by 16. And that gives me 22.5 for my exterior. So my interior is 180 minus, second answer, 157.5. Okay, the next 4 are even easier because all they want is the exterior, so that's going to work with the 360. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, 360 divided by 10, so 36. 1, 2, 3, 4, 5, 6, 7, 8. 360 divided by 8. 45, I knew that one already. 180 minus 45 should give me 135. And it does. Oops, I'm sorry. All I needed was the... Well, that is the biggest degree symbol I ever did see. So, stick with the exterior. 1, 2, 3, 4, 5, 6, 7. 360 divided by 7. 51.42. Oh, sorry, it said nearest tenth, so 4. 51.4. It said that up here too. And this is the only one that's affected, 164.3. Let's see. 1, 2, 3, 4, 5. 360 divided by 5. And that's 72. Okay, so that was pretty easy, right? When I'm making this recording, it's so nice and sunny out. Okay, let me line up again. Hopefully it is when you're watching the recording. I feel like it keeps raining and raining and raining. There we go. All right, exterior. I have to make a note to myself because this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 360 divided by 11. I think I have that on the other page already. 32.72 repeating. I'm not going to round it because I can see the repeat. 13, 360 divided by 13. 27.7. 20, 360 divided by 20. 18. 1, 2, 3, 4, 5, 6, 7, 8, 9. 360 divided by 9. It's going to give me 40. 360 divided by 16. 22.5. 360 divided by 23. 15.7. Okay, now we want the interior, the sum of the interiors, all right? That's the one where we have to figure out how many triangles there are, okay? Hold on, I can go down to 25, yep. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, so 7 sides, which means 5 triangles. So 5 times 180, 900. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 sides, 8 triangles, 180 times 8, 1440 for the sum of the interiors. 1, 2, 3, 4, 5. 5 sides, 3 triangles. Okay, so that's 540 for the sum of the interiors. 1, 2, 3, 4, 5, 6, 7, 8. 8 sides, 6 triangles. I think it's 1080. 6 times 180. Yep. Okay. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 sides, 9 triangles. 9 times 180, 1620. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sides, 7 triangles. 7 times 180, 1260. Okay, regular quad, we know that one, 360. Dodecagon. Dodecagon is 12 sides, so 10 triangles. So 1800, 180 times 10. 18, so 16 triangles. 16 times 180 is 2880. 13 triangles for a 15-sided polygon. 13 times 180, 2340. Okay. Now the last one, the last two actually are critical thinking questions. What is the exterior angle sum of a 500-agon? Well, what do we know about the sum of the exteriors? Always 360, so that was really easy. They love this question on the Regents, so you have to be careful with that one. Is there a regular polygon with an interior angle sum of 9,000? If so, what is it? Well, here's what I would have to do. If the interior angle sum has to be the number of triangles, all right? So I have to see if 900 is divisible by 180. And it is. Okay. Oops, sorry, 9,000. 9,000 divided by 180. It is, it's 50. So there's 50 triangles. So if there's 50 triangles, then there would have to be 52 sides. So that would be a polygon with 52 sides. Let me just check something. Okay, so try one more. Let's say is there a regular polygon with an interior angle sum of 800? Well, let's see. The 800 would have to be the sum of the measures of a triangle. And when I do 800 divided by 180, I get 4.4 repeating. So there would never be a polygon that has an interior angle sum of 800. Okay, so that's it. You have a homework worksheet to do. Please make sure that you submit both the classwork and the homework. Have a great day.